All right, and it turns out that I have the privilege of being the last presenter. So, good evening, everyone. My name is Hooman, and I'm the founder and CEO of Everix Optical Filters, where we reduce the cost of manufacturing of high-performance optical filters by more than an order of magnitude. High-performance optical filters are nano-layered materials, sometimes made of hundreds of nanolayers, engineered to selectively filter specific frequencies of light while transmitting the rest of the light spectrum. They're used in a wide range of applications, and they're one of the key components in many optical systems, but there's one major challenge. The challenge is that they're at the same time one of the most expensive components in systems. $1,000 per square inch is a typical retail price of these high-performance filters. We are transforming that $14 billion industry with a radically new manufacturing process. A process that is similar to the process of making millions of miles of optical fibers, but using that for making really high volumes of optical filters. As you can see in that picture in the middle, we assemble all the layers of optical filter in a much larger scale than they're supposed to be eventually, and then we simultaneously shrink all the layers down by a very large factor to bring them down to the nanoscale that they're supposed to be to function as a high-performance filter. So the process not only reduces the cost of manufacturing by more than an order of magnitude, but also produces the thinnest, by far the thinnest, 5 to 20 times thinner and lighter optical filter compared to the best in the industry. It also produces the only flexible and shatter-free optical filter, which makes it really beneficial for several applications on Earth and in space. So we currently have over 220 paying customers, including 3 Fortune 50 customers, incorporating our product into their next generation products. I'll give you a couple of examples. Well, one example for now. Fluorescence microscopy and imaging or sensing has been one of the key and most precise methods for life science and medical diagnostics. And it has been so far limited to benchtop lab scale, very expensive instruments in centralized labs. They use that for infection, for cancer detection, for a number of different health conditions. That device is now gradually making its way to point of care and eventually portable and eventually wearable and at some point disposable version. But every one of those devices use at least 7 pieces of between 2 and 7 pieces of optical filters. Imagine what our scalability can do to that. Thank you.